Hi, and welcome to my first presentation at the Qt Developer Days. I'm Samuel Gaist, partner at the EdelTech Ltd, currently also working at the KDAB Research Institute. I've been working with Qt since more than a decade, starting with 3.2, which is pretty old by now. I'm starting to contribute to Qt for about 2 years on various modules, including Qt Core, Qt Mac Extra. I've been working on several things like documentation, bugs fixing, and new features. You may also know me through the Qt Project Forum, where I'm a mad scientist. So, now to our talk. First, I will take a real-life example of what it is to work with an invisible device. Then I'll go more into detail what those devices are, then how to develop with them using test-driven development. I will then make a little demonstration, and then we'll have some time for question and answer. There will also be some live coding during the session to show you the different stage of development. So, the real-life example, Etchiscan. Etchiscan is a product from EdelTech, which is a software to control film scanners, as well as acquire multimedia data, such as sounds and images. The scanner itself runs on a proprietary firmware, who talks with a proprietary protocol. To pilot the scanner, we're using USB. And for audio and video, well, it depends on the type of scanner. Some of them are using SDI, others are using frame grabbers. So each type of scanner must be supported. This is the application. With that application, we can control the camera on the scanner and the scanner itself. Excuse me. The different part that you see all goes through the point where at some point or another there's an invisible device behind. The image comes normally through a camera, but not every time do you have a camera to get these images. Next to them, you also have the color wheels that will influence how the camera will take the images. Again, the camera is not always there. In the middle, you can see the usual control bar for a CD player, where you can stop, go forward, go backward, and this one talks with the scanner itself. So then again, the scanner might not always be there. So why does the application need a scanner? Well, the device is needed because it can be, how do you say that? It exists in different versions. So each time you connect to one of the scanner, you have to adapt the software to talk with the scanner and with its different device hardware options. You also need the knowledge of the scanner to know how you will get the images and the audio. So, what's an invisible device? It's something that you can't move next to your desktop. If you take the example on this image, the scanner weighs more than a motorbike. So you need at least 3 persons to transport it. It's about 2 meters long, 1.5 meters high, and 50 centimeters deep. So it's not something that you can have beside you and that you can move. An invisible device might also be something that doesn't exist yet. You probably already worked with hardware people who told you, yeah, almost done. Next to it, you will have it. And most of the time, that was 4 months ago. It may also be a system that already exists, but you can have it. Why? Because it's somewhere locked in the basement. You can only remote control it, or it's in some place that you can't go Typically, you're in Europe and you should go to America to test it. Or it may be also something that you want to make software for, but you can't afford. Not everybody can buy a Ferrari to write the system in it. And it's also something that you might have on your desk, but your friendly vendor came in, explained to you that yesterday's evening he sold it to a customer and it ships today, with a bunch of features that is also sold, but you didn't wrote. Real life experience. Never talk about features with a vendor. For them, it all exists, not for you. So all in all, if you can't have one, it's invisible. So how can you write an application for something that you don't have? Well, simply put, you write a mock object. A mock object is something that will behave like your device, but that you will control. So you will write your application as if you had your device beside you. But luckily, you don't need all the hassle to move it. Once you have a mock object, it's cool. It's somehow a virtual device, but still, you haven't yet done something with it. You have to use it in your application. So for that, you will use an adapter object. The adapter object will be what you will interface with your application. So the mock object is, in this case, the scanner, and the adapter will be the part that will control the scanner, that will communicate with it. So your application will only use the adapter. It doesn't need to know that under the adapter it has a virtual device or a real device. For him, it's completely the same. To do that, we will also apply TDD principles. Has everybody already done some TDD? Well, almost a third of the audience. Nice. So let me do a little reminder. TDD is a philosophy that proposes to work in short cycles. First, you start by writing a test. You're already thinking, well, I don't have the cost. Why do I write the test? Well, that's exactly the goal. You write the test for the functionality that you don't have yet. And you make sure it doesn't pass. If you write a test that passes for a functionality that you don't have, there's something wrong. Next step, you write the code that should make the test pass. You can write it quickly, maybe even messy, but it should make the test pass. Once the test passes, you go around your code and you clean it. Never let the messy code inside your software. It will bite you back. Because you will do something like, yes, this allows to do that, now I know it. You come back 6 months later on the exact same piece of software and you don't remember why you wrote it like that. And if you modify it, you break the test, but you don't know why. So one of the benefits of TDD is that you will know how your code works. Since you wrote the test, you wrote the code to make it pass, you know how it works. You will also know that your code actually works. If the test doesn't pass, it doesn't work. It will also be a help for other developers that will look at your code to understand how it works. You can't always write simple and clean code. Sometimes you have to interface with an external library, which might be way more complicated than your code, which requires a lot of boilerplate code. But if you have written tests who show how this library works, you will yourself understand the code, and the other will also understand. Take, for example, Qt. You have lots and lots of tests in Qt, all of them validating the functionalities. So you can also use them as a base to understand why something has changed between Qt 4 and Qt 5. For example, QURL. It's changed a lot between the two versions. And something that changed are not necessarily, user-facing. But by looking at the test from QURL, you can understand why it changed and how it changed. Last point, and that's one that is really important, you will know when you break something in your code, because the test will fail. So don't forget, run your tests. They are as useful as when they are run. There are several levels of testing. You have unit tests. The unit tests are generally meant to work on a single class. You test each and every aspect of that class. Not all classes are, are asking for tests. You can have simply container classes, which when you write them, you see that you have a parameter, it returns a value. That was the parameter first, so it's simple. But as soon as you have something more complicated to do, you have to test it. Then you have a level that is a bit upper, you have functional tests. With functional tests, generally, you will keep several of your low-level classes, put them together to do something. Typically, the mock object for your device, you know that it works within the defined protocol that you are using. Then you will use the adapter. So the adapter itself will use the mock device. But is it working correctly? Both together. That's what you have to test. And then, again, a level upper, you have your system tests. Once you have every piece working well, you have written your application. You know that your application works well. But you never know what your user will do with your application. So you have to also test it for some funny stuff. Because when you test the application yourself, you always do the same thing. You start it, you click on a menu, you load something, you click on play, you click on record, and everything works. Fine. But your user, they won't do that the first time. They will start your application, see a shiny button, click on it. Hey, it doesn't work. Why? And maybe, just maybe, you forgot something. And this use case wasn't covered. So you also have several possibilities to do system testing. You have software like Squish, where you can automate something. But when you are connecting to a device, you can't rely only on Squish, because you have to interact with the device. Again, for the film scanner, what you have to do, you have your scanner, you have your movies, you have to load them on the scanner, you have to lace the film onto the other side, then you have to make sure that everything is okay, then you load the movie, and then, and only then, you can start to write with your application, to work with it. So, for that, you also have the technique that's called scenario-based testing, where you write a scenario like for a movie that you give to your testers, and they have to follow it step by step to ensure that the functionality as you designed it is working, and that you haven't forgotten something. And the last case is that they have their free will. At some point, they have to try to break your application. Because if they can, you can be sure that your user will do it the first time. Now we'll go on something a little more practical. What's a good TDD project architecture? Most short applications are generally contained in only one folder where you have all the sources, and you'll be done with it. Applications that requires a bit more involvement are generally cut like that. You first have your project, then a subdirectory where you have your apps. You will not always have several apps. But for most big projects, you always have several apps. Then you have your libraries. And each library is contained in a specific folder. Those folders are always unique, and it will be easier to link to those libraries if they follow a strict structure. The libraries will be also made like that. All sources are in one subfolder. You don't want to mix them. As you can see also in Qt, you have several folders. All the sources are only in one, which has several other subfolders, but that's another problem. You don't want to mix your testing code with your actual running code. Unit tests should be at the same level as your sources. So again, you can easily grab the classes if you need them, or link to the libraries. So, how to use TDD with Qt? You use the QTest framework. The QTest framework allows you to easily write little tests, bigger tests. You can test non-graphical classes, you can test graphical classes, and you can also do benchmarks. But basically, the structure is always the same. You create a testing class, which derives from QObject. That's mandatory, because all the system works on the base of QObject. Then you create the private slots that you need to use to test your class. And at the end, you have QTest main, which will create the main application that will run your tests. You also have the QTest GUI application, GUI main, where you will have a real Q application or QGUI application to test your classes. And at the end, you all will have the mock file. Because you're already trying to use a CPP file, you have to give a hint to Qt that you are trying to implement a QObject in that file. So let's practice a bit. We will write a little test. So there, exactly what I thought. Qt creator. There you have the test. So it's the basic test that we needed. You can see there the classes, the unit test itself, the mock part. Here you have the exact same thing that you had before. You have the apps folder, the libs, your code library that will do amazing things, and then the test that would validate that these things are amazing. So right now, if we run this test, what should it do? Should it run or should it fail? Nice, it fails. Won't really be practical. So, to make it pass, you could change that to true, but it's not what we want. We want a new functionality. So now, we need to get to the cool class. So, my cool class has an add feature for advanced mathematics. What we want to do now is test that feature. So, we go again to the test. We change the name of the test because it's not phase 1. We will test add. Always give meaningful name to your test functions, because testing my class doesn't really tell what you will do, even if you test everything. So now, we want a cool class. And we want to test that the result is good. Since add int, the result, and we want to test that 1 plus 2. Should be good, right? So it fails. That's bad. So let's see where it failed. How? No, it's all right. It's all working. Just that I couldn't remove. Hopla. Where's my code class? It's there. So my code class returns 0. That's bad. It's not an addition. So right now we will write the code that will allow us to make the test pass. A plus B. Sounds good for an addition, right? So, run it again, and now the test passes. Congratulations. You worked your first unit test, and it's working. And one thing that's really cool with unit test is that if you make a little modification to your code, the little typo that you didn't saw, and they are easily done, well, bam. It fails immediately. So now that we know how to write unit test, let's go to the next interesting part. We want to write something for our device. So the first thing to do is to know your device. How does it work? How can you communicate with it? In the case of the scanner, it's a serial port. Nice. It's USB, and you have Q serial port. It's a good thing. But for other devices that could be remote, such as a service, you don't always have access to internet, even in these days. Try to go in the Swiss mountains, far and deep. You won't have any network. But you still want to program, because we might be crazy in Switzerland. So once you know how you will connect to your device, you will also have to know how you can talk with it. Some devices have protocols. And I don't mean the lower level protocols like TCP, but you send commands, you have answer, or even some just send something. If you take, for example, temperature sensor, some of them just send the temperature. Regularly, always the same. You have to do that, to know that, so you can write a mock object for that. So in this case, if we have either a serial port, a network, or something like that, we can use QIO device. So here's your mock object. QIO device is a really cool class. You can do several things with it. You can write your own file writer. You can write several things that's completely unrelated with files. And so is our case. Our mock device will be something like a virtual scanner. So the mock object itself will simply accept the commands, answer to them like it was the real device. The only drawback with that is that you don't have hardware failure with that. But currently, it's not your worst problem. You just want something to talk with that acts like your scanner. So here, for example, you have a mock device. It's really simple. You don't need much code to write one. Now that you have a mock device, the next step is to define the controller, the thing that will do the link between your application and your actual device. It's what we call the controller. So you have to define how your application will interact with the controller. You may use signals and slots. You may use events. You may even want to use something as crazy as command line. But believe me, your user won't. You also have to think of the level of abstraction you want to give to your software. if you are to reuse your component, like the controller, you have to understand that you can't always map one-to-one what your device does with what your application does. Typically for a scanner, you know that it can load movies, you know that it can go forward, backward, you can change the speed. But how do you translate that to something that's usable to a user and to you as a software writer? So once you define that, you can write your adapter object. The adapter object will simply take a device, in our case, a QIO device, and with that, you simply have your mock object given to your controller and your application. The device itself doesn't change how the adapter works. It just works with the adapter. Now, we have a controller. So, for a little session, I wrote a piece of software that you will see after that. Always lucky to have saw there. So the controller itself is pretty simple. You have the device here. You have some functions that you want to give to your application. So you want to make your device move forward, stop it, go backward, and if possible, you want to change the speed of the thing. So in itself, the controller is not very complicated. But it's the piece that will allow you to work with the mock object or the real device. So you're going to say, how can we test something like that? You have the test for the scanner controller. Since we are using a QIO device to send commands, you can replace the IO device with a Q buffer. The Q buffer is simply an IO device that writes to a Q byte array. So, using your adapter, you can send your command to your device. Then you take the content of the Q byte array, and you can see whether the command goes all through the controller onto the device. Here you can see that I've made things a little bit complicated on purpose. The device itself accepts several commands. As you have seen, we want to go forward, backward, stop it, and change its speed. But it's not always practical to write a test for every single slot of your controller. So what I did is that I used Qt's QObject meta system to write a test where you can easily add new method to your QObject and test them. You can see on the upper part, up there, you have test controller data. Test controller data is a special case in the QTest framework. The underscore data functions allows you to create or generate data that will be used by your test. So, each column represents a variable that you will use in your test. And each new row represents a test that will run. So here we have 3 new rows. It means that the test under will be run 3 times. And you can do it as much as you want. So here, with QFetch, you get what your new row should give you. And then you simply run the test. Here you can see that I've used the QMeta object to call the slots on my controller. So I don't have to write 3 lines of slots with 3 lines of tests. I just call the methods. Then I'll get what was sent to my device and compare. Did I get what I should have And in this case, yes. You can reuse this technique every time you have a mock device that's using QIO device. You know what you should have, you know what your controller should do, so you can compare and verify that it's working. Any questions? Okay, let's continue. One thing that is important when you are doing some device-related stuff is that you should actually detect the device. Because trying to always connect to the device, not verifying if it's there or not, you will lose time. And also, your customer will wonder why your application starts, doesn't work, doesn't show anything. That's why you should try to detect the device. If you take, for example, the scanner you saw earlier, it works on serial device. So, a serial device has an ID that you can check. If you know what kind of ID you have to check, you can verify when you start up that it's actually there, or if it's not. For network-related devices, you have, for example, Bonjour, the Apple version of the ZeroConf protocol. That protocol allows to have a device that announces itself through a defined name and interface. So you can try to connect to that, search if it's there, and if it's not, you can do something else. So the detector is generally more an enumerator class. So it will give you one answer. Is it there or is it not? Based on that answer, you can use a factory to create the right device. Be it the actual device or the mock device. And then, once that is done, you can simply set the device on your controller. Now, I will make a little demonstration, because the theory is cool, but the demonstration is better. So, no, not this one. I know. So now on my desk here, I have a little device, which should be a scanner. It should be rotated at 90 degrees, but I don't have long enough cables, sorry. So now you have your famous scanner, and you would like to work with it. So nice. You've written a remote. So currently, what the device does is simply send the content of its camera through the network, and you can make it move also through the network. So here, let's go forward. See, it's running. You have the wheels that are currently doing something. And maybe it's go too fast, so you would like to slow down a bit. Cool, you have your camera, you have your scanner, and it's working. What happens now is at some point you have your friendly vendor that comes in and say, hey, I sold it. So now it's a bit of a problem. You don't have any device anymore. You can't control it. It just doesn't work. See, no more static moving. So, no problem. You just quit the application. Yep, wrong button. You come back here. There. The enumerator told you, hey, I can't find a scanner. What do you want me to do? Well, here I've made two different possibilities. You have the virtual scanner, which is simply a QIO device that will act as your scanner. And I also written a remote scanner. Because since our scanner was working through a network, you can also create your own simulator that will act as if you had the real device. But again, it's just a mock device using a different I/O device. So now, if you take the remote scanner, you click OK, you have again your application that is working. You can make it move, we can go forward and go backward. And I've written that so that you will again have the nice color bars, but it seems that the GStreamer pipe has failed. So, when you're working with invisible devices, in short words, you have to use a mock device so you can write your application, continue to develop it, add new features without having to touch the actual hardware. Doing that using tests, you will have at any time a software that you know is running and working. If you modify something and run the test and it breaks, you know immediately why. And using mock devices, you can also create demonstration mode for your software. If you take EdgeScan, for example, writing just a demo mode that simulates the camera and the scanner didn't make sense. We had a mock device. So the mock device could be used for demo mode, even if it was mainly created to allow our development. Thanks for coming by. I hope you enjoyed it. And if you have questions, feel free to ask.
Please raise your hand clearly so that I can run with the microphone to you.
I have actually two questions a bit related to each other. You have shown tests which basically test the happy path. This usually is something we do quite often as developers. Mm-hmm. Do you have any tips for actually how you tackle failures? And then the second question related to that, sometimes as a developer you actually forget about errors or you don't know about any possible errors that might happen. So how do you tackle that?
So for testing unusual use cases, you have what's called fuzzy testing. So that's typically used when you have input like strings. You know what strings you would like to have. In this case, the protocol is using commands, so that's strings. So what you do with fuzzy testing is that you generate random strings and you give them to your classes and see how it behaves. If it works in the meaning that it throws an error, then you know you're doing something good. If the class tries to do something with it, then you know it's something bad. So it's more how you would like to in the end, write your test. If you have such cases, you need to extend the range of the typically give invalid values, give strange things, give unusual characters. Try to do everything that another developer will do. It's not also a penetration testing. You are not in the security field. But you can simply try to give a defined set of invalid value or just to generate them. And you can do that quite easily when you are using the underscore data function. You can write a for loop, put something in it, and it should make the test fail. When you have a problem that doesn't seem to have any sense, there's always a good old technique with QDebug. You verify each step of your algorithm. It might not be the fastest, but from time to time, it's the easiest way. Does that answer your question? Other questions?
It's a similar question to the one before. Do you write several mock objects, sometimes that it fails? Or do you control one object so that it sometimes returns errors for the testing?
It depends. But most of the time, if you want to test also real-life problems, you will write a mock object where you can connect a widget to it and add failure sequences. So you write only one mock object that will allow you to do everything, because you could also reuse that mock object in your tests. So you know the good path, you try the good path, and then you are starting to add errors with your mock objects. So it's better to do only one. The only exception is what I show here. So it's, since we were using network, you can have a local version of your mock object, or a bit more evolved version where you use a QTCP socket to talk with your mock object. But in the end, it's the same mock object. So you have the same good path and bad path. Question here.
How far would you go with mocking objects? I mean, would you try to mock everything that has like a, I don't know, a public interface for the outside? And if so, do you find it helpful to have like, for reproducing bugs in the field, to have like a recording of all input and to be able to replay that same input in your lab, I mean, indoors?
Well, again, it depends on your use cases. Typically, for edge scan, we needed a mock object to actually make the things run. We hadn't any knowledge of the failure path, so we couldn't write for. But if you have a device that should be that it's a critical part of a production line, you can have half a mock-up device. You need to have something that's complete, where you can check every parameter of the device. In the end, it's almost like if you wrote a simulator for the device, which is not necessarily a bad thing. You don't always have the time for that. We all have our schedules and pressure, but it's better to try to do something that's almost as complete as the metal. So you know that if you have something that's going wrong in the production stage, you can reproduce it by your computer, because you know that you won't have the device beside you to reproduce that. So yes, you can also add logging features to your mock device, so you know what's exactly working right now. If you went to Kai's presentation just before dinner, you saw that there are now quite a few new possibilities for logging that could be really useful also for mocking devices. Other questions? Yeah.
Assuming you have an existing software which test coverage is very poor, and, and you attempt to improve on this, how would you tackle such an issue?
Well, code coverage and unit testing are not completely unrelated, but are generally also working in parallels. If the code coverage is poor, it means that you have too much unreviewed, unknown code in your software. So either get that code out. You have now you have Git for that. You have the history of your code. So removing code is not a problem. But keeping old code that is rotting will give you a problem at one point or another. If it's something that is useful, then it should be used by your application. If it's not used anywhere, put it away. If it's something that is used but doesn't have any tests, add a unit test for that. So gradually you will clean up the code, you will add tests, and you will improve your software altogether. Another question? So, thank you for attending. Hope you enjoyed it.